fairly informal. There's going to be a little opportunity for you guys to have some peer learning during this as well. So first, I just want to get a sense, how many people here are graduate students? Is almost everyone here a graduate student? And are there any postdocs? A couple? One, maybe? How many of you are thinking about a career in academia? So most of you are. Okay, well what I'm going to try to do is talk a little bit about what it is to be an early career faculty member, and one of the things that you're going to need to do, as you're probably already aware, is to write grants. So I'm going to talk a little bit about how you can approach effective grant writing. And then please ask questions along the way. And I'll tell you some about Research Corporation, which is located here in Tucson, and our niche is funding early career faculty. So we're a place that a lot of faculty starting out come to with some of their earliest grants. Since you're at the biosphere, I found this cartoon from the Whole Earth Catalog, which was a publication back in the many years ago, and this is a cartoon that of the biosphere when it was one year old, and it was still actually, I think, inhabited at that point by the biospherians. And you can't actually read the caption on the cartoon. This is supposed to be a representation of the biosphere, and I think that it says on the door there, please keep the damn door shut. Thank you. But at any rate, that was a cartoon I found on the biosphere that I enjoyed. So, Research Corporation for Science Advancement. The vision of our foundation is what we try to do is provide catalytic funding with grants, conferences, and advocacy. And what we support our early career faculty, like I just mentioned. We're looking for innovative ideas for transformative research. We are interested in the integration of research and science teaching. So how do you bring your research into the classroom and integrate those activities? We're very interested in supporting interdisciplinary research, and we like to do things that we believe build academic cultures that embrace these values. Now, we are actually the second oldest foundation in the country. We were established in 1912, so the year that just started, 2012, is our centennial year. So it's going to be a pretty exciting year for us. We were founded by Frederick Gardner Cottrell, who is a physical chemist at the University of California, Berkeley, and he invented the electrostatic precipitator, which is a means of electrostatically capturing particulate matter from smokestacks. So it was one of the first green machines. Back around the turn of the century, it was a tremendous problem. I mean, we still have smokestack problems, but not the kind of problems they had of belching this particulate matter. He figured out how to capture it. That electrostatic precipitators are still used, and he used the proceeds of his patent to form Research Corporation. He was very philanthropically minded, and he believed that rather than personally benefiting, he wanted science and society to benefit from his invention. And so he founded Research Corporation so he could give back and support scientists. So it's a really neat history, and over the course of our 100 years, we've made awards to 40 people who have gone on to be Nobel laureates, and we've made we've made over 10,000 awards and funded many great pieces of science in the history of our foundation. So that's a great history. We operate with a private endowment, and our funds go primarily for projects in chemistry, physics, and astronomy. And here's a picture of our founder, Fred Cottrell, who was a fairly dapper gentleman. Okay, so for those of you who might be at the APS March Meeting, we are going to have every year we host a reception there, Research Corporation, and this year we're going to have a bigger event celebrating our centennial, and everyone who attends the March Meeting is invited to come. So if you are at that meeting in Boston this year, please come to our reception. And it's going to be guest hosted by Eric Mazur from Harvard University, who some of you might be familiar with. Okay, so what is our focus? I'll give you a little bit more detail. The idea is that we partner with universities and colleges to provide resources for early career teacher scholars. And the idea is to establish successful ongoing programs. We want to integrate education and research. We want to effectively involve students. And the key idea is that we want to partner with institutions, so we're looking to make awards to environments where we feel that there is significant support for the faculty, where the likelihood of our grants being successful is much greater. So we don't simply give money to the individual, we're giving money to an institution to support an individual, and we have to also see that the institution is making significant contributions to the support of that individual. And I'm going to talk in more detail about that in a minute. Some of the program generalities, we have a number of different programs, and as you get to the point where you get into academia and become a faculty member, then you want to go to our website and look at the details. But the generalities, we have programs for primarily undergraduate institutions that don't grant PhDs. So your liberal arts colleges, your large institutions like the Cal States, Cal State Long Beach, Cal State LA, and so on, that are master's level. We have a program that's geared towards those institutions, and here again, it's funding for early career faculty. We want to promote collaborative opportunities across disciplines, help faculty integrate their research and teaching. We try to leverage institutional change to create a climate where research is much better supported, and we want to always involve undergraduates in any project so that they get the opportunity for active learning through research, which we firmly believe is one of the best forms of undergraduate education. So that's an important part of any award that we make. If you go on to a research university and are a faculty member there, we have programs for the research universities, and here we particularly look for innovative research, and we want to develop outstanding researchers to also be outstanding teachers. We want that commitment to both. And we're trying to build a community, a sustainable community of teacher scholars. We call this program the Cottrell Scholars, and we have a collaborative of all the past Cottrell Scholars, about 250 over the last 15 years, who can participate in that collaborative, and we advocate for the teacher-scholar model, and we try to promote a culture of excellence in science education. So that just gives you a little sense of who we are and what we do, and I'll give you a few more details as we go along. But I want to get into effective grant writing now. And what I want to talk about is resources and expectations. And the thing is, as you become a faculty member, you're going to get provided with a lot of resources. You're going to get provided with resources internally from the institution that hires you, and then you're also going to be trying to gain access to external funding, external resources through grants to foundations like Research Corporation, or to the federal government, the National Science Foundation, the Department of Energy, and so on. So you're trying to get these resources, but the key thing to realize, I think, is that whenever you're provided resources, they always come with expectations. It's never the case that somebody provides you resources and doesn't have expectations. And the best situation is if you're really clear on what those expectations are. Because if you understand what they are, then you actually have a chance of maybe fulfilling those expectations. And I think it's unfortunate that sometimes in academia you have situations where people are provided with resources but aren't very clear on the expectations. So it's a good exercise, and you guys are starting out as graduate students, but even as graduate students you probably already have, from your interactions with your mentors, you probably already have some idea of the type of resources. But this is a nice exercise. What I'd like you to do, and I'm going to let you guys talk to each other and do this, talk to the person next to you and take a few minutes. I'd like you to try to write down some of the types of resources that you think will be provided to you as a faculty member when you start out a career in academia. If you get hired at one of these institutions, a primarily undergraduate institution or a research university, you're going to be provided a variety of resources. Do you have any sense of what they are? Write down a list a little bit, talk to the person next to you or the person behind you, and see if you have some ideas of what things are going to be provided for you. It's a good exercise to go through, and then I'll put up my list. So take a few minutes and do that, and talk to one another a little bit. And if you happen to be near a faculty member, you might even be able to get their input a little bit. Somebody talk to you? Okay, let me go ahead and put up my list, and then, my list is not complete, but we can talk about some of these, and then maybe you had some other ideas and you can throw them out, but it's not uncommon that at any institution that you go to, particularly if you're going to an institution where you want to be engaging in research as well as teaching, that you're going to get a startup package of some kind. And it's going to vary depending on if you're a theorist, if you're an experimentalist, if you're at a small college, if you're at a major research university. But to just give you a sense, at the primarily undergraduate institutions that don't have PhDs, liberal arts colleges, state universities that are at the master's level, what we've seen over the last few years in the proposals that come to us is an average startup fund on the order of $50,000 for these small colleges. If you move to research universities, you're talking about startup funds that might be $500,000. There are even examples of people that have startup funds over $1 million. And now, in order to start, particularly if they're experimentalists, they need to buy a significant amount of equipment. They need significant, maybe building, actually changing labs, rebuilding the interior. So starting right off with the startup package, that's a huge investment, a huge resource that's provided to a new faculty member. So certainly if somebody provides you that kind of money and hires you, one thing you should know is they want you to succeed. It would be very foolish of them if they did that and they didn't want you to succeed. And the other thing, though, is that they really expect that you're going to do a lot of things for that money. They're not expecting you to just give it to you as a gift. Some of the other things that you see for beginning faculty, sometimes they have reduced teaching loads for a period of time while they get established, develop their labs. It's very common for institutions to have to provide matching support for grants. There are a lot of different types of grants that require an institution to match. And that's what I was talking about when I mentioned how we look for institutions to partner with us, and so do other agencies where we see that there's significant support from the institution as well as support from the external granting agency. It's common to have travel support for the purposes of research, attending conferences, attending schools like this type of school. travel support for both faculty and students, equipment funds, sometimes there's student stipends or postdoctoral stipends. It's not uncommon now for there to be pre-tenure sabbaticals, so that after your second or third year, you might have a semester or even a year where you have off from your teaching duties and you're devoted to your development of your research. So, did people think of other resources, or did people think of these resources when you were writing down your lists? Are lots of you already aware of this? Okay, so the thing that I want to draw to your attention is that this is really a substantial amount of support if you go into a faculty position, and so there's going to be expectations that are going to come with this support, and there rightly should be. The question is, what are those expectations? And so this is the next part of the exercise. Talk again among yourselves and write down in general what are the categories, the kinds of things that are going to be expected of you once you're given these resources as a junior faculty member as you work your way towards a tenured position. So what do people think you're going to do if they give you this kind of support? Oh, like there's a question here.
Like, do professors get trained before they start the job, or do they learn in the first day they get the job? Like,
do professors get trained before they start the job?
Because we don't know anything about these things, right? So when do we learn this?
Well, that's a really interesting question, and the level of training you get varies quite a bit. There are institutions now that specifically as part of their graduate programs are trying to get some training. There are institutions that try to provide some teaching experience, for example. There are individual mentors who try to do mentoring to prepare students to go into academia, and then there's a lot of students that don't get preparation. Sometimes you come to schools like this and there's a talk provided by somebody like me, so you get a workshop development opportunity. But there isn't a standard of training like there would be if you became a high school teacher. It's very different, and so that's why it's important to try to learn about these things as you can. Okay, so that being said, this is a good opportunity for you to share with on a peer-to-peer basis, what do you know about the expectations that are going to come with the job of being a faculty member? This is that exact learning opportunity, hopefully, that will help you a little bit. Okay. I'll go ahead and start putting some things up, and let's see if we agree or overlap. So let's see. Well, one thing is that if you're given this kind of support and you're expected to start up with research, you're probably going to be looking at trying to write proposals for external grants early on. And it's probably a good idea to write multiple proposals given the fact that we live, kind of paradoxically, even though this is probably the wealthiest time in human history, and we're probably in the richest nation that's ever existed by some reasonable standards. It's also a time of very constrained resources, and so it's extremely competitive to get external funding. So starting out, you're going to want to start writing proposals, and we're going to talk about how to write effective proposals, but that's certainly going to be an expectation once you've gotten these kind of resources that you go out and try and get more resources. You're going to have to set up your lab when you start out, or if you're a theorist or a computationalist, you'll have to set up the environment in which you can be successful. Maybe you have to set up computer clusters, or you have to, right from the beginning, start creating what's going to make it possible for you to carry out your research. And that, starting out, you can't wait to do that for several years. You're going to want to be involving students in almost all academic situations. It's very important that your purpose that you're there for, just as you guys are students now, you're going to be involving students in your research, and the sooner that happens, the more productive you can do that, the better. All right, then you're going to have to revise your proposals in the second year. Chances are that the proposals you wrote, there's a good chance they weren't funded, or maybe one of them you did very well and one of them was funded. The other one that wasn't, or the other couple that weren't, you still want to revise them and continue on. So this is an ongoing process of, you're going to be doing, if you're a faculty member, chances are you're going to be doing a lot of grant writing. I think the faculty members in this room would probably support that. Okay, let's look at some other things. You have to start presenting your results. As results from your research come out, you have to go to conferences, you have to get your results out in a variety of ways, but you have to tell people about what you're doing fairly early on. And of course, you want to start publishing your results. And as I'm putting these numbers up, these are very approximate numbers, and they're going to vary from institution to institution. But at least it gives you a sense that once you get going, you need to get your results out, and you need to get published in the peer-reviewed literature. The science isn't complete unless it's out in the peer-reviewed literature. By the way, if people have questions or comments as I'm going through this, please.
What if you finish publishing the result in the first year?
What's that?
What if you have finished the project in the first year?
Oh, then get those results out then sooner. What I'm putting these numbers up is to give you a sense of, you better get going, and you want to have production. If you exceed this, you're doing better. This is, it doesn't mean that you can't do better than this. This is just to give you a sense, and again, it's dependent on institutions. Then you have to go out and you have to renew grants. You have to go through the process of trying to continue on. So again, through this whole process, you're going to be writing a lot of grants. That's one of the things that I want to get across to you in the academic position. Let's see, there's other things too. Well, you got to do a good job teaching. And of course, what constitutes, great teaching really is institution dependent. There's some institutions that are going to have a much different bar for what they expect and what they want you to accomplish. But, and it's possible there might be, some institutions have a fairly low bar, that's true, but in general, and particularly now, I think it's moving more and more to having higher expectations for teaching. So, right off the bat, you're going to be expected to do a good job teaching. It goes back to the question, where do you get the training for that? You don't always get the training, so it's an awful lot of work. Fortunately, there are a lot of resources. For example, the American Physical Society, the APS, and the American Association of Physics Teachers, they're now, they've been doing this for about a dozen years. They put on a workshop for new physics faculty, and about half of the new physics hires in the country go to this workshop annually, and that gives you some really excellent training on how to be an effective teacher. And if you do become a faculty member in a few years, and that program is still going, which hopefully it will be, it's been going for a dozen years, you want to go to that workshop if at all possible. That's a way where you can get some effective input on how to do a good job teaching. You're going to be expected to do service as part of faculty governance. That means that you're going to serve on committees for your department, or you might serve on a committee for a college. or you might become involved in your professional society like the American Physical Society and serve on committees for that society. So part of your time will be participating in the running of your department and making curriculum decisions and so on. So service is part of what you have to do. And if you can do all this well, hopefully in year 6 or maybe even sooner if you've got those results out in year 1, you'll fly over the tenure bar. Okay, but what I want to impress on you, and probably did people think of some other things as well on the list? Because this is not an exhaustive list by any means. Or anyone, faculty members, want to comment? Or all right, I guess not. So the key thing here is that you are going to be provided a lot of resources, but you're also going to have some significant expectations. Expectations are going to be in the context of the particular institution that you're at. You want to be as clear on them as you can. The clearer you are on those expectations, the better chance you have of succeeding. And one thing that will be part of it in almost every institution, if you're serious about doing research, is you're going to be writing grants for external funding.
I would actually put on the top of that, that doing great science is the main reason. All of these things are important, but unless you actually, can do science and have fun, what's the sense of doing this whole thing?
That's absolutely true. And so what I put great teaching, and I should probably revise this and have great science as well. That's absolutely right. I mean, so again, as you put this forward, obviously you might get publications, you might get grants, but if people don't judge the science to be good, and that's certainly possible, if people, if you get reviewed at the time, you go up to tenure and the decision is this really isn't, great science, then you may not be successful even if you've done all of this. I think that's absolutely right. Yes?
So another thing that not everyone may be aware of is if you go to an undergraduate institution, a liberal arts college, great teaching and a little bit of research may very well get you tenure. At a research university, great teaching will get you nothing except the thanks of your students. And that's not to be minimized. I think it's really important to be a great teacher, but it won't get you tenure. You have to do great science.
Right. And I would say that even at the liberal arts colleges, particularly as the standard is going up in terms of the quality of research.
You're going to have to do some research these days, but there is a divide.
Right. Right. And so when to give a talk like this, it's really important what you're saying. These expectations have to be contextualized for the type of institution, and then not only the type, there's tremendous variation between institutions that fall into a broad category. So you have to know for your specific context. But nonetheless, whatever type of institution you're at, you're going to be engaged in activities like this. Yeah?
I'd also like to add something to what Misha said. These startup packages in research institutions now, not necessarily liberal arts, but research institutions are now very, very generous. And external funding agents understand this. And so I would take a little issue with the first bullet. The first exercise really should be to get your lab going and get some results before really you even start writing proposals seriously, because they recognize that you're funded very well and they want to see results to make sure that what you're going to propose is actually going to be viable. So your first order of business is to get results, especially experimentals.
And that's the reason why you want to do it, right? That's the reason why you want to roll this.
So you should get preliminary results, which you can put in your proposal, and that will very much strengthen your proposal.
Right.
So I want to ask a question specifically of you, because what Wendell says is absolutely correct about the NSF and most of the major funding agencies. I have the impression, at least historically, that it's not necessarily true of a research corporation. That is, a research corporation will give a young faculty member a grant without having that proof that that they're already productive.
That's true. And particularly in our program for undergraduate colleges, we allow people to apply in their first year, and we allow them to apply without results. They have to demonstrate that they have a really good idea and that there's a good chance that it will succeed. The idea behind that type of grant is to be a seed grant where you then can get the results to move on to the NSF. At the research universities, our Cottrell Scholar Program, we allow people to apply in their third year. At that point, they undoubtedly are in a position where they do have results when they're applying to our program. So it's less of an issue in that context. But yes, again, trying to do something like this is trying to do something very general. And so what you're saying is very true. But my hope here is to get people thinking about the kind of activities that you have to be engaged in. And then to understand that you have to find out for your institution what is specifically expected for the job that you're going into. Okay, so let's try another exercise. What are the 3 most important things to do before writing a proposal? Talk to your neighbor and write down what you think the 3 most important things to do are before you write a proposal. All right, let me put some things up, and there is no perfect right answer to this question at all, of course, to this type of question. So you're all going to have your own ideas, and that's fine, but I wanted to stimulate you thinking about a couple of important things to do. So the first thing is, if you're going to apply to a program, whether it's from Research Corporation or whether it's from the NSF or DOE or whatever, Petroleum Research Fund, you have to read the guidelines and the frequently asked questions. Because one of the biggest mistakes that people make when they write proposals is they write a proposal that's not suited to the program that they're writing it for, and they haven't really read the guidelines to understand what that program is looking for. What is the emphasis? Is the program looking for is it looking for applications moving applied results forward? Is it looking for fundamental science? Is it focused in a particular area of physics? Is it broad? Is it a broad call? What are the things that they want to see you be able to demonstrate? Does it require preliminary results? And so on. If you don't read the program guidelines carefully, you can't prepare a proposal well. And so you also want to then read the frequently asked questions to make sure that you really have addressed everything. And sometimes program guidelines are detailed, and you might have to spend a day reading them or a day and a half reading them, or and you might have to go back and refer to them. But it's a very small investment compared to spending months preparing a proposal that's not appropriate for that program. So what are some other important things to do? Oh yeah. Then, so this is a little bit of a joke, obviously. But then you can talk to a program officer or a program director. But the thing is that I want to emphasize that, and Wendell, you'd probably agree, that when someone calls you up to ask you questions, you know, we certainly are very open to talking about what you want to do and trying to help understand if it fits into the program. But if somebody calls me up and it's clear that they haven't read the most basic things about the program, they haven't looked at the frequently asked questions, I feel like I'm wasting my time. You know, I want to talk to you after you're really familiar and have done a little investment. So that's really important. It's going to be much more productive if you do that. And just for us, when the time comes, that's our website, so you can get in touch with us very easily. But I'm going to actually go on to some of the other items that you probably wrote down, but what are some other things that people said for most important things to do before writing a proposal? What are some ideas that people had? Toss them out, because I'm sure these weren't the only ones.
Make sure it hasn't been done before.
Make sure it hasn't been done before, so originality. Anything else?
Make sure that your idea is really well defined.
Okay. Some other? That sounds good. Others? You guys all came up with ideas. Were those the only ones?
I would say look at some previous proposals that got funded.
That's a very good idea. Other ideas? Yes?
Have some way to tie in your proposal with broader impacts.
Okay, so tie your proposal in with broader impacts. That probably depends on whether the program requires broader impacts or not. But there are many programs that do, so that goes to read the guidelines and make sure that that's something you need to do. But that's a good example of where you might be trying to do that and it's not required for a program. Other ideas? But that is good, that is usually needed.
You need to have motivation and know, like, why is your work important? Like, why did someone fund it? And how it fits into, like, the context of other work.
Right, what's the significance of your work? Right. Other things? Because I'm going to come up with a few others. Those are all good, though.
Have an estimate for the resources required.
Say that again?
Have an estimate for the resources required for the experiment, let's say.
Have an instrument for the resources?
Estimate.
Estimate, okay. Yes, you have to know what the resources are that are required so that you can ask yourself, do I have the resources with what I have and what I'm going to get from this grant? Are those sufficient resources to make this project possible? Right, that's absolutely right. Other ideas?
Timeline.
Timeline? Yeah, some sense of how the work might progress and what you want to accomplish in a series of steps. Yeah. Okay. Let's see. So successful grant writing. We just talked about the significance, originality, feasibility, and addressing the audience that's going to be reading the proposal. These are real basic things. These are things that we judge on at Research Corporation, and you want to know if what are the fundamental criteria that another agency is going to judge. But when we write our guidelines, we say we're looking for you to demonstrate significance, originality, feasibility, and then you should be pretty clear on who you're writing to. Who's going to be actually judging the proposal. So, how do you know if something's significant? How do you decide if something's significant? And how do you show that something's significant? How do you actually do that? I mean, how do you choose an idea? Yeah?
Well, you read papers from the past and see what problems other people have faced. And if you have a new idea that can address those issues, then that would be obviously a good thing.
Okay. Other? I think that's definitely good. Other? How do you know something's significant as you're starting out? Yeah?
Investigate what practical applications it may have.
Okay. Potential applications. Does it have any import beyond what you're doing? Other ideas? That's certainly something that could demonstrate significance. Other ideas? From the back? No, I'm looking at our esteemed colleagues in the back. If they want to throw something out.
Well, you can show something about the level of interest in the community for the thing that you're doing. The trouble is that there's a tension between seeing that there's a lot of people interested in it and doing something that's new. And that's always a kind of paradox, that you want to do something that people haven't done, but you want to show that it's something that people are interested in. And how do you show that they're interested in it? Because they've written papers about it and things like that. So You know, one good way for an experimentalist to say, there's all these theorists who are interested in this, but nobody's ever done it yet, and I'm gonna.
Right,
But this is actually a very important point that Bill made, because this is one of the reasons why, for instance, an organization like NSF tends to be rather conservative in the way we fund, because we tend to be judged by our peers. And I'm not sure if you have somebody who is thinking way out of the box, let's say Planck or Einstein, who they're doing things you don't know it's significant, it's so far out. Right? And the question is, how do you deal with that? And it's exactly the point you're making.
There is one way how to address this, is to basically do a fraction of his research.
Right.
You know, and that's the way how one can.
Right. Right. So, I mean, this is a really hard question. You know, how do you show significance? But one thing goes back to knowing your audience. You know, who's going to be reading the proposal and deciding whether it's significant or not? And for Research Corporation, we ask you to give us a list of potential external reviewers, and we also feel free to choose our own external reviewers. And we try to look to people that are known to be leaders in a field that have been very successful. So one operational definition is, think about, you should know who the leaders in the field that you're working are, you know, who are the people that are doing great science. And when you come up with an idea, you can ask yourself this question. If somebody read that idea, would their reaction be, I can't wait to see the paper that results. I really want to know the answer. Or do you think their reaction would be, eh? And that would give you a little bit of an indication, is that's, you have to write to people who want to see the result when you're done with the research. And then you have to be able to articulate why they want to see that result. Okay, how about originality? What does originality mean? This goes back to your comment too. But.
Well, someone already said you got to make sure it hasn't been done before, and you have to make sure that what has been done before isn't so much like what you're proposing. It's the old wafnium thing. You know, if somebody's already done it in wafnium and you're proposing to do it the same thing in wafnium, it probably isn't going to fly.
Right. So there's some sense of, first of all, does it look like you're just making an incremental advance on what you just did as a postdoc or what you just did as a graduate student? Does it look like, you know, it's just a slight twist? Or are you actually coming up with an idea that seems like it's your own idea, it's independent, it has to build on what you know, it has to build on your experience, but it has to show the potential to lead to something that's sustainable, your own ideas, your own program. You have to demonstrate that you can think at a level that you're generating really interesting ideas for great science. Okay. Comments, other comments on originality. I mean, one thing that definitely kills a proposal for us is if it looks like you're just doing what you did as a postdoc. If it looks like you're being a glorified postdoc. If it looks like the idea came right from your thesis advisor, you know, that's not going to fly very well. You have to somehow show that now you're thinking on your own. You are an independent scientist. You know, that's the level that you have to get to. Okay, feasibility. How do you demonstrate feasibility? And I want to say this is key, because you can have the most significant idea. It could be incredibly original, and people definitely want to know the outcome. But if you don't convince people that you're the one that can actually get there, that you can actually carry the project out, then it would be crazy to give you funding for it. It would just be a waste. Right? So feasibility, how do you demonstrate feasibility? Yeah?
You know, like the key challenges and have a plan for how to overcome them.
Right? Absolutely. You have to identify what are the challenges, and you have to show that you have a plan. So say more on that. Other people. Yeah.
I think Professor Wiener already mentioned this, but already give some results, some preliminary results on your research.
Absolutely. If you have preliminary results that show that what you're planning, that definitely adds towards feasibility. That you're making progress, you're already making progress. Maybe one of the key ideas looks like it's going to pan out. What happens if you discuss key challenges and you have a plan? What might happen if one of those challenges, if it turns out different than you expected? Well, maybe you show that there's a plan B, that if something doesn't work out quite as you expected, that doesn't mean the whole project is dead. What are some other things?
One of the things I look for is, did you do a back-of-the-envelope calculation, find out what the signal noise is going to be? Does this make any sense? Is this, if you did a back-of-the-envelope calculation, you found out the signal noise is going to be 1, it's probably not going to work because things are always going to be worse than what you thought. Now let me make another comment.
Oh, well, let me stop on that comment. That will kill a proposal so often. If you haven't done something like that, a very simple back-of-the-envelope calculation, and the reviewer does that and says, hey, this doesn't make sense, and why didn't they do that? Proposal dead. That's it. So that's absolutely critical.
So there's another point, which is more of a philosophical point than advice about proposals. You think about how the experiment's going to work, and you think of all these reasons why it's not going to work, and you should have answers for those in your proposal. But in your heart of hearts, what I'm telling you is this. Don't think too carefully about the things that are not going to make it work and decide you're not going to do it. Because it's a lot easier to think about why something won't work than to think about how you're going to solve a problem when you actually are confronted with it face to face. Don't put this in the proposal because it's not what they want to hear. But I'm pretty sure that if I thought about all the reasons why laser cooling would work, carefully enough, I never would have done it. But, things worked out pretty well. So, it's more of a philosophical point. It's, don't be scared to do something because it looks like it's really going to be hard. Don't do something stupid. I mean, don't go off and do something when you're pretty convinced that there's no way it's going to work. But on the other hand, don't be afraid to do something just because it looks like it's going to be hard. You're more clever than you may think you are. And it's hard to tell how you're going to solve a problem until you've gotten to that stage. But that's not what constitutes your proposal. These are the things you do when they give you the money, and then you do something more clever than what you talked about in your proposal.
But I do think it's true that you have to demonstrate some courage, and that goes back to significance and originality. And then you need to make a case for feasibility. And I'll put up a slide here on a little bit more details on feasibility, and I'm getting close to being done here. But I do want to talk about addressing your audience a little bit. It's a really good idea. In fact, I think it's critical that you know who's going to be evaluating your proposal and who's going to decide whether it's funded or not. Because one of the things that sometimes is lost is the whole process of deciding how resources are allocated is a human process. It's human beings that are making judgments, and they're going to be subjective judgments. And that some of them are going to do a good job, and some of them are going to do a poor job, and some of them are going to do a middling job. But the point is that humans are going to exercise their judgment, and you have to know how to write effectively, and you have to have a sense of who the audience is. So for Research Corporation, we actually have a very multi-tiered process. So as a program officer, I read the proposals, and if it falls well outside our program or it's really flawed, I could kill it at that point. I select external reviewers who are experts in the field, and we ask you guys for suggestions. That's part of the process. That's part of your proposal. So you have to do a good job suggesting people to have a good proposal. We send it out for external review. We get those back, and then on top of that, we have an advisory committee that gets to see my comments, that gets to see the external reviews, gets to read the proposal, and that's a standing committee of scientists with a lot of broad experience on proposals, and they get to look at all that, and they make a recommendation to the foundation, and we generally go by their recommendation. So you're going to have, for us, when you're writing, you're going to have a combination of people that are very expert in your field and people that are just good general scientists. And you've got to be able to communicate the ideas to both of them. So one of the things you don't want to do is you don't want to have a jargon-laden proposal that's just, lost by everybody except the guy that was sitting next to you or the person that was sitting next to you in your lab. But at the same time, it has to be sophisticated and it has to show somebody who's an expert in the field that you really know what you're talking about and you really understand. So there's a tension there as well. And you have to think about how to write a good proposal. So there was a very good book that came out by Malcolm Gladwell. Some of you maybe have heard of him. He's a New York Times best-selling author, a journalist, and he wrote a nice book on the science of decision-making. It's called Blink. And if you haven't read it, probably most of you guys are too busy in graduate school to be reading something like that. But it's a great book summarizing a lot of what psychologists understand now about how people make decisions. And actually, that field has made tremendous advances over the last few decades. But one of the things that they understand is particularly experts make a lot of decisions very rapidly. So they look at your proposal and they might read the first page or the first half of the page, and even if they don't intend to, they've already made up their mind. Okay? They look at that proposal and they've made up their mind. And if you've done a bad job on your introduction, you haven't really made it come across on why this is so important, why this is so exciting, if it's poorly written and doesn't articulate clearly, then you have to have the whole rest of the proposal try to turn their mind around, which is unlikely. So you have to also think of how you're effectively writing, effectively communicating excitement, effectively communicating your ideas. Okay, that's really important. Comments?
Along those same lines, this may seem completely trivial. Proofread your proposal. Proofread it again. Have one of your friends who is a native speaker of English, if you're not, proofread it again. When I get a proposal and it's full of grammatical errors and spelling errors, I'm thinking, did this person care when they wrote this proposal? Now, it probably shouldn't be like that, but it is.
Right, and actually I'm not sure that it shouldn't be like that because it goes back to the fact that this is a human enterprise. Real human beings are going to read that and they're not going to like it if you have a bunch of grammatical errors. They're not going to like it if you have spelling mistakes. And they're not going to believe that you're a careful thinker. You're presenting an impression on people. And it's really important that you do a very good job doing that. So that's part of the whole process. It's also a really good idea if you know somebody who's gotten an award from that agency, somebody who's working in your field, have them take a look at your proposal. If you have senior people mentoring you, have them look at your proposal. Ask people for really critical, hard feedback. Don't ask them to just say, oh, you're doing a good job, that's great. Ask them to tell you if they were going to take that apart, what that feedback would be. It's much better to get that before you put the final proposal in than after you put it in. All of that can improve your chances of being successful.
I have a question.
Sure.
Do you write theoretical and experimental proposals separately, or if you have a project, you could fund for both theory and experiment?
For research preparation, we fund both theoretical and experimental projects.
Meaning that when you write a proposal, right? I mean, for a problem, you can have theoretical aspects of research and experimental aspects. So it's one package that would solve all of that.
That is certainly possible. That would depend on the specifics of the project and if it makes sense that you're doing that. And if you can articulate that as really a project that holds together and that you're capable of doing all of that, then yes, it might make very good sense.
On the address to the audience, I was wondering if I could add something. It's especially the case in a place like NSF, which covers all of physics, and we've heard, for instance, from Misha, there is more and more of an overlap between some parts of condensed matter physics and atomic molecular and optical physics, for instance. And if you submit your proposal to, let's say, AMO physics, you should keep in mind that the reviewers will be AMO physicists. Mm-hmm. So you should at least make an attempt to connect. It sounds more like condensed matter because you're doing two-level systems with Josephson junction set. Make sure that it's really worded in terms that an AMO physicist will, yeah, that's really our indication. That's what it should be for. It's really important to do that.
Yes.
I was going to say this later, but what is being danced around here is to make sure what you write is easy to read.
Right.
Make sure the reviewer can pick out exactly what you want to do, exactly why you want to do it, and exactly how you're going to do it. They make it very clear. In NSF proposals, you have to have a front page, which is a summary. And as we've already heard, everything you want that reviewer to know, the reviewer should be able to make a decision based on what they read in that summary. Now, you put the details in the back. You have 15 pages to add details. But you need to make very clear what you're going to do, why, how, and what you expect to get out of it. And even talk a little bit about longevity. This is a one-off that sometimes is not so good. If you, especially if you're young, if you can make a case where you will be able to do this for the next 5, 10 years, you don't have to spell out exactly what you're going to do, but you need to make it clear that this is a direction that you're going to devote your significant part of your life to.
Right. Absolutely everything there I agree with.
One of the things that I've seen in several proposals from young persons is be modest. Don't try to ask for a postdoctoral researcher and 2 graduate students if you have never mentored a graduate student. It's not going to happen anyway. you will not get the money anyway. So ask for a graduate student, be modest with the first proposals. You have to get into the system. Then later you can ask for more. And you still
Right.
get it.
But and this is the kind of thing where
discouraged.
Right.
Your proposals might be decline for 1 year, 2 years, 3 years. Actually, that's a very good point to have a good idea of the typical size of a brand in a typical agency. So, for instance, if you go to AMO's theory and ask for $300,000 per year, it's not going to happen.
But
And
see,
they will
and these,
reduce the dollars,
right.
they just kill your proposal.
And these are actually the kind of questions, after you've carefully read guidelines and really thought about what you want to do, this is the kinds of discussions that you can have with the program officer. Well, what is the size, typical size? What kind of resources is it reasonable? You can also talk to, more senior colleagues to get their input on what's plausible for all of that. So, let me throw up 1 or 2 more slides, and then I think we need to stop, but let's see what I did. Well, these are just some basics, and we've already talked about most of these things, but, it's probably worth throwing them up there. When you're going to state the problem and the scientific significance, and people have mentioned this, you have to put your problem in the context. You really have to show knowledge of the field with complete up-to-date references. A lot of proposals get killed when key references are left out, and it indicates the person isn't really familiar with the field they're working in. And going back to the human part, if you have a reviewer who feels they wrote one of the most important papers in the field, and that paper isn't cited, they might not react positively to that. That doesn't mean that you just cite everything in the world. You have to cite it in the context of why it makes sense to cite it. But you don't want to leave out important ideas. You need clearly stated hypothesis or a really clear key idea. What is this project about? Going back to the first page. And it's up to you. This is, it has to be, easy to read. It's up to you to make a compelling case for significance and originality. I've seen many proposals where the reviewer writes and explains what the proposal is about much better than the person that wrote the proposal. And that doesn't go over real well. And also there's a lot of times when a key idea or a key point that would make the case more compelling is left out. And you read the proposal and you can imagine what that is, and you can even imagine the person probably knows that. But you still might not get funded. It's up to you to make the case, not up to somebody else to make the case for you. Okay? And I think I'll show one more slide on a plan of procedure or making the case for feasibility. Oops, let's go back. There. So, this is where specificity and details, really saying what you're going to do, how you're going to do it, what the instruments are that you're going to use, what the specific steps are. Look at, possible alternative routes. What are long-term goals and sustainability, which was just mentioned, something that can live on its own beyond, a short project, particularly starting out. it should be clear that you have the potential of attracting more funding if this is successful. You want to, certainly for us, and I think it's probably true for other programs as well, you want to explain and show how students are going to be effectively integrated into the project. Not just I'm going to use a couple of students, but what are they actually going to be doing? What are they going to learn? These are all things that come across and make for a much stronger proposal. So, I think I'll stop at this point, and we can have more discussion on those.
Yeah, I think it's really great.
Yeah.
So thank you so much. I don't want to stop the discussion, but we're going to have dinner, and you will be there for dinner, and I think it's been a very long day, so maybe we should take some fresh air. Yeah, please go ahead. Yeah, please.
First of all, I want to thank the Research Corporation, because when I got started, they funded me.
There you go.
And so one of the things about the Research Corporation